All right, here we go with unknown integrals. These are sad integrals. Nobody knows them. Just kidding. They can take up some paper and they can be a little bit tricky. So these are definitely ones that where you might want to work the same integral a couple of times to make sure that you can get where you're going and not have a big mistake or issue. So evaluate e to the x cosine x. Now, let's just keep a couple things in mind here before we get going on this. So number one, if you take the derivative of e to the x, so if I have y equals e to the x and I take the derivative, I get e to the x. And if I take the derivative of that, I get e to the x. On the other hand, if I integrate all of these, integrate, they integrate to e to the x. With cosine x, if I take the derivative of cosine x, I get negative sine x. And if I take the derivative of that, I get negative cosine x. And if I take the derivative of that, then I get, negative cosine, I get sine x. And if I take the derivative of that, I'm back where I started. So both of these guys lend themselves to repeating, and no quick, easy way to get out of it, okay? Well, going back to our tips and tricks, and keeping in mind how integration by parts works, where we're going to have the integral of u times dv. This is going to be uv minus the integral of v du. Okay? So while we're working on this part, remember that we wanted to pick u in very specific ways. Something where you took a derivative, it generally got easier, and something where you integrated, it generally didn't get much more difficult. So what to do here? Well, in our tips and tricks, one of the last things we wanted to pick to be u was a trig function. So in this case, we're going to let u equal e to the x. It was actually one of the ones that we wanted to try and use as a u. And so that means that dv is going to be cosine x. All right? So here we go. U equals e to the x, dv equals this. Integrate u, take derivative of u and integrate v. Hello, Sports Center. All right, so here's our initial setup, okay? And what we're going to do is we're going to do our uv integral v du. So u times v, that's going to be e to the x sine x. Okay, minus the integral of v du, so that's going to be e to the x sine x. All right, so we can't integrate this guy either because we're basically the same place that we were right here. So we're going to do parts again. U is going to be e to the x, so du is e to the x dx. Dv is going to be the sine of x this time, and dx. So when you integrate sine of x, you get negative cosine x. So we're going to set that guy up the same way. So here we go. By the way, this is y equals. So now y is going to equal e to the x sine x minus, and looky right here what we've got. We need u times v. So that's going to be negative cosine minus the integral of v du. And looky here, we're minus e to the x cosine dx. All right. Well, now what do you do? E to the x cosine x, that's basically back to this guy, which is where we started. So what's going on here? Well, let's write it out and simplify it just a little bit. Y equals e to the x sine x minus negative e to the x cosine x plus the integral of e to the x cosine x dx. Can you see that we would keep going and keep going and keep going with this guy? We'll take one more step.
Do you want cherry?
Sure, I'll take cherry. Oh,
A cherry.
all right, that's okay. Good toss.
Not in sports for a reason.
That's all right. Okay, so to wrap up this question, I'm just going to make a small change here. I had to pause for a second, and I noticed these aren't y equals, by the way. Remember, when you're doing integration by parts, you've got this integral equaling this stuff. So for my integration by parts, my integral is equaling this stuff. So this is the integral of e to the x cosine x dx all the way down. So this is the integral of, all the way down right here, all the way down right here. So what we're going to do is clean up one more step on this guy. E to the x sine x plus e to the x cosine x minus the integral of e to the x cosine x dx. Now, remember what this equals. This equals the integral of e to the x cosine x dx. And notice one more time that this guy and this guy are exactly the same. So if we want to know what that integral equals, we can actually move this whole thing over by adding it to both sides. And when we do that, we get a brand new thing. We get 2 times the integral of e to the x cosine x dx equals, and then on the other side, we've got this e to the x sine x plus e to the x cosine x. And then if we divide all of that by the 2 right here, and add a c, we've got our integral. Because then when you look at the integral of this guy, e to the x cosine x dx, that is this answer inside the box. All right. So there's a few steps to take on this, and some of these can take up some paper and some space. But again, these are ones that if you practice just a little bit, you should be able to get to where you can get to the end and find where your integral starts to repeat itself so that you can simplify it.